or maybe you find it difficult understanding some parts. Okay, but I'm going to go through again. You should, one thing you should know that I even didn't show you guys the requirements of the question. I didn't show you the requirements of the question, but I can tell you that we've done the A and B without even showing you guys the requirements of the question. So now I'm taking it again so that you guys will really appreciate what we did. I'm saying that they've given you the demand function in a form of a price function. P is equal to 9 kil minus 0.2 kil squared. And we know that total revenue is equal to what? Selling price times quantity. Now, the first question is asking that we should calculate the output level at which the total revenue is maximized for 6 marks. Okay. Now, so first of all, we have to know the total revenue because they didn't give us total revenue. They just gave us a price function. But by virtue of what we know, total revenue is equal to what? Price times quantity. So if you have the price function, you have to multiply it by quantity to get the total revenue. So if the price was, let's say, 50, you multiply the 50 by kil to get your total what? Revenue. Please, you understand? Likewise, in this question, hey, my network is now very slow. Oh, Kufikra. Oh, why can't connect to this network? Hello.
We can hear you.
Okay. Yeah, you guys will be able to hear me, but my screen is a bit slower. Okay, so I'm continuing. So the question is saying that we should find the output level. That's the quantity at which the total revenue is maximized. So to get that quantity, first of all, you need the total revenue. And I told you that total revenue is the selling price times quantity. So we know the selling price to be 9 kil minus 0.25, 0.2 kil squared. So we multiply it by kil and you get the total revenue to be this 9 kil squared minus 0.2 kil cube. So I believe you all understand up to this place. Then here, to get the optimal revenue, because we are saying that we need the output level at which total revenue is optimized, maximized. They are the same thing. If you hear maximize, optimize, it's the same thing. Okay. So to get that output level at which total revenue is maximized, I told you that it is when the first derivative of the function is equal to 0, then the function is optimized. So when we differentiate the function for the first time and equate it to 0, then the function is what? Optimized. So here we have to differentiate the function. So 9k squared, when we are differentiating, the 2 will fall to multiply the 9, giving us 18. Then we reduce the 2 by 1. Then here too, the 3 will fall to multiply the 0.2. That's it here. Then we reduce the 3 by 1. So this will give us 18 to the power 18 kilo to the power 1. Then the other side will give us minus 0.6 kilo squared. Please, do you understand?
Yes.
So from here, we know that the function is maximized when the first derivative of the total revenue is equal to 0. So we have to equate what we got to 0. So when we equate it to 0 here, I wanted to omit the decimal. That's why I divided everything by 0.6, 0.6, 0.6, so that the decimal will cancel out. Then I'll be left with just Q. So here, I got 0 being equal to what? 30Q minus Q squared. So when I got that, what I did next was to factorize out 1Q. So 1Q is out, it will be left with 1 here. Then here 2, it will be left with 30 because the Q here is just 1. So when you take that 1Q over there out, you'll be left with what? 30. So then I said equate this to 0, then equate whatever is in the bracket also to 0. So when you equate both to 0, now Q is 0, then here to Q becomes 30. Q will become 30. So therefore, at this quantity levels, this is the output levels at which the function is optimized. Oh, my optimize is not coming. Now, optimization can be either a minimum or a maximum. So, but they are asking for the output level that will give you what? A maximum revenue. So we are interested in maximum. So, I told you this will be minimum and this will be maximum. But we are interested in the maximum. So how do we get the maximum? Then I said that we get the maximum when the second derivative, when we differentiate it again. So we have to get maximum, we have to differentiate the total revenue again. So we differentiate it again. From here, this is the first derivative. So we differentiate it again. Now, when we differentiate it again, sorry, this is the first derivative. So when we differentiate it again, this one will multiply the 18. We still get 18, but here the Q becomes 1 minus 1, giving us 0. Now, any number to the power 0 is 1. So 18 times 1 will still give you 18. That's it here. Here to the 2 will go and multiply 0.6. Then we get 1.2. Now, then the 2 will reduce by 1. You should remember the rule of differentiation. I said that when you have y is equal to ax to the power n, the dy dx is that the n will multiply the a, then the n will reduce by 1. So when the n multiplies, it has to be reduced by 1. So that's why the 2 was reduced by 1 to here. Okay, so when we do that, this becomes our second derivative. Then I said that we will put the quantity levels we got, that's the 0 and the 30 that we got, we would have to put them into the second derivative. So when we put it in the second derivative and we get a negative number, then that's a maximum revenue. But when we get a positive number, it means that that output level will give us a minimum revenue. So we use the zero first and we got a positive number of 18. So that's a minimum revenue. Then we used the 30, giving us a negative number of 18. That's a maximum revenue. And we tested it. When we put zero into the total revenue, you see that our revenue will be zero. That's minimum. But when we put 30 there, you see that our revenue will be 2007. Please, do you have any question? This is question one. Any question? I'm going over again. I'm saying that at break even, our profit is either zero or our total revenue is equal to our total cost. We know how to find profit. Profit is total revenue minus total cost. So it's either we use it from this side or this side. But the question is requiring that we use it from this side. So we would come back to that. But I'm saying that our total revenue is equal to our selling price times quantity. However, the total revenue function has been given as this. That's 5,000 kilo minus 100 kilo squared. So that's it. But our total cost function is not given. And we know total cost is equal to your total fixed cost plus your total variable cost. So this is our total fixed cost. That's the 35,000. It says that the fixed cost for the period was 35,000. That's it here. It says that it observes that the fixed cost of the product is 35,000. Okay. Now, and the unit variable cost is 500 kilo. Sorry, 500 per unit. So it means that to get the total variable cost, it is the unit variable cost times quantity. So here it becomes 500 times quantity, which is what? 500 kilo. And that's it here. And we know that profit is equal to what? Our total revenue minus our total cost. So to get our profit, my pie there is bad. To get our profit, it becomes this, all of this minus all of this. So 5,000 kilo minus 100 kilo squared minus or minus 35,000 plus 500 kilo. So from here, the negative will affect everything. So our profit becomes 5,000 kilo minus 100 kilo squared minus 35,000 minus 500 kilo. Now, you know that because this is 5,000 kilo and this is 500 kilo, they are like them, so they can add up or subtract. So our pi now becomes, let's bring the one without scale first, 35, negative 35 kilo plus 4,500 kilo minus 100 kilo squared. Please, you understand? Hello.
Hi.